Hi, this video is third in the series of work power energy. We're going to look into work in detail in this video. So let's, starting from the previous video, assume that you have a force, but this time the force is in this direction, right? And this force results in a displacement of S. So this is the direction of displacement. This is the direction of displacement, right? And this force is making a small angle theta. So and the force is of course applied by a person, right? And someone like you who is pulling this block, and the work done is defined by the work done by you or your force F is equal to the force in direction of motion into the displacement. Now, what is this force in direction of motion? To understand this, I would like to go back to trigonometry, the triangle, which all of you would remember, right? So if this is 1 and 2 and this is 30 degrees, or let's say this is 30 degrees, so what you have here is 2 sine 30, and that's 1, and what you will have here is 2 cos 30, and that is equal to root 3, right? Right, so that's coming from trigonometry. So applying the same idea, the horizontal force, or the force in the direction of the motion, is F cos theta. So in general we say that the work done by the force is equal to F cos theta, because this is the force in the direction of motion into the displacement. So work done is F cos theta into S. So to understand this better, let's talk about all the different scenarios that you may have. So A. So you have 500 Newton of force, and your displacement is 50 meters. So here the angle between your force and displacement is 0 degrees. So your work done is F cos 0 into S. So that's 500 into 1 into 50. That's 2500 joules. Then you have the second case, wherein let's assume the force applied is in vertical direction, and again your displacement is 50 meters. So here theta is 90 degrees, and your work done will be F cos 90 because this is 90 degrees. This is the direction of displacement, and with respect to here it is 90 degrees, and in this previous case that is 0. So your work done is F cos 90 into S. That's 500 into 0 into 50. That's equal to 0. So what we mean here is not just work done, it's work done by F. Now there could be some other force F2. This is F1. There could be some other force F2 which was responsible for this motion, right? Now there has to be some cause, without which there would be no displacement. So the work was done by some other force due to which the displacement happened. When we say work done by F1 is 0, that means that this force didn't cause the displacement. There was no work done by this force F1. Okay. C. So let's assume you have the scenario wherein you have force applied at an angle, and this theta is 30 degrees, and this is your F, and this is again your S. So in this case your work done would be F cos theta into S. By the way, when we say work done, it's work done by F always implicitly, right? So that's F is let's say it's 500 Newton into cos 30 into S is 550 meters. So that's cos 30 is root 3 by 2, root 3 by 2 into 50, and that amounts to 1250 root 3 joules. So you can see here that this is significantly smaller than this. So the maximum work is done when cos 0 is, the maximum value of cos theta is 1. That's a max it can take. Cos 30 is less than 1. So this quantity is going to be lesser than 2500, right? So you have the final scenario wherein, let's say you have the force is in this direction. You have the force in this direction, and your displacement is continuing in this direction. So can you give me an example? Can you pause and think of an example? Well, an example could be that your car is moving at a velocity of, let's say u is 10 meters per second, and you are braking. This is a braking force, so you're slowing yourself down, right? So in this particular case, your theta is, your theta is 180 degrees. So your work done is F cos theta into S, that is equal to 500 cos 180 into 50. That's minus 2500 joules. So if your work done is greater than 0, this implies your object is gaining speed due to the force. And as you remember, this is a cause and this is your effect. And if your work done is less than 0, like in this particular case, implies your object is slowing down due to force. Now, there are a lot of interesting questions that gets asked based on these concepts, and some of them are some of the questions are has overloaded meaning, but let's talk about them. Right, the first type of question you get is, hey, here you have a coolie, and this coolie is lifting a heavy block, and due to this block, of course, the gravity is acting downward. So this is your gravitation force, and this is your vertical force applied by the coolie, F vertical by coolie, to hold this. Right, now the question gets asked, what is the work done by coolie in moving from point A to point B, which is basically a displacement of S. So work done by Cooley is equal to how much? So first of all, this question is incomplete. So the question should be, what is the work done by Cooley against or not against, by Cooley, Cooley's force, Cooley's force F vertical, right? And so that obviously is going to be 0, because your F vertical cos 90 into S equal to 0. But this does not imply Cooley did no work. Just like the previous example, there must have been some force that the Cooley would have spent in walking in horizontally. He must have applied some force horizontally for that movement. So it does not imply Cooley did no work. So please keep in mind that the work done by Cooley's vertical force, F vertical against gravity, is what did not result in any motion, right? Did not displacement. So that's what it means. The second type of question you get is, let's say you have a uniform circular motion, right? The uniform circular motion could be due to anything, right? It could be at the center you have a string and a ball, or maybe sun and the earth, or whatever, right? So you know that in all these cases there is a centripetal force Fc, and there is the velocity is tangential. So if you think about a very small displacement in the arc, this delta S, and this force, the centripetal force, is always perpendicular, right? So work done by the centripetal force is Fc cos 90 into delta S. Now this delta S is very small. This is very small, right? So that's again equal to 0. So the work done by, so centripetal force in uniform circular motion, or rather in any motion, any circular motion, does no work on body. So this is the other thing which you need to keep in mind.